All right, welcome back. This unit is all about Chapter 9. I know we kind of jumped over Chapter 28. Chapter 28 has a lot of the math that you've already done in your math modules. So I kind of jumped over that. It's a lot about solving angles, circumference, stuff like that, right angles. So this unit here is all about dimensioning, Chapter 9. We're going to start on page 119 in your book. Now, when we start looking at dimensioning on prints, every company uses a different style, every engineer uses a different format. When we start getting into this unit, typically what they're going to do is they're going to give you enough information to solve any kind of dimension that you need to on that print. They typically don't put every dimension on that print because it starts to get a little cluttered. Usually you got to calculate a dimension or an angle or a width or thickness or whatever it may be. So as we get in here too, they're going to break out a couple different styles of dimensioning. Some of them are common, some aren't that common, but I'm going to go through a couple different styles. We're going to go through that and go from there. So as we dive in, go to page 120 here, and as you go to the bottom left-hand corner, extension and dimension lines, they're very, very important. The book shows you have two basic plates, typical butt joint. If you've been in the lab, you already know what that is. So here's a butt joint. They give you the overall dimension. Here's my extension line. Remember we went through that, the alphabet lines? Here's my extension line. Overall dimension here, let's say is 4.125. They might give you this dimension, 2 inches. So as you can see, they didn't give you the overall. You probably have to assume that this piece is 2 inches also. So our gap is basically 0.125 or an 1/8 inch. So as you can see, there's a very basic example where you're going to have to calculate a few dimensions. Now as you go to the lower right hand page of 120, you can see that, for example, I'm going to use a tiny little rectangle. Same thing here. So we have our top view, front, and right side. What does that mean? So, your front is always going to give you height. It's spelled right. In length. Top view is always going to give you the length in width. Same here. You're going to have height and width. So depending on what view you're looking at, that's the dimension that you're going to get. So each view has, and it shows you right on page 120, follow that example, it's going to give you certain dimensions. So, now we're going to start diving into some different types of ways they dimension. Typically, like I said, they're not going to give you every dimension on that print. You're going to have to calculate. You're going to have to use your brain a little bit, sit down, do a little calculations and stuff like that. And I have a ton of examples that we're going to be using in this chapter and throughout the rest of this competency. And whenever you have questions, be sure you ask your instructor for assistance. So like a broken chain dimension that you see at the top page of 121, they have an object that looks like this. It gives you the overall length. Here's our extension lines, dimension lines. Let's say this is 4.5. They give you the dimension of this. 1.5, and they give you the dimension of this here also. So This is an example of broken chain dimensioning. You can see the chain's actually broken. They give you every dimension. Now if you sat calculated 4.5, so overall length 1.5 plus 1.5 is 3. 4.5, so then you would calculate that that's 1.5 also. So, a couple different ways. As you go to the model below it, it's giving you the chain dimensioning of this. They don't give you the overall length, so then they give you another dimension here, 1.5. Now be careful with that chain dimensioning. Main reason being because you can have error. Now if I was going to measure this part out, I would not measure from here to here, and then put my tape measure at this point right here, measure out another 1.5, measure, because you're going to have error of where you place that tape measure. If it was me, lay the tape measure out here, measure all 3 dimensions from one point with that tape measure. Even when you get in industry, when you start fabricating parts together, make sure when you're measuring, you measure off 1 point, measure as much as you can off that 1 point. It's going to be a lot more accurate. Instead of moving your tape measure 10 or 15 different times, every time you move that tape measure, you have a chance of getting some error involved. Angular dimensions, I'm not going to go through all these. You can kind of read through the book. If you have questions, like I said, we're going to set up an actual time where you can come in here and all it is print reading and weld symbols through the Ultimate Instructor. Angular dimensions, I'm just going to use a T-joint. So here's a T-joint. Let's say we put it at a weird angle. You can see that they use, for example, if I can't get the dimension lines in there, they might be like that. This might be 15 degrees. You see how they're doing that? They're giving you the angle. So this would be 165 degrees. This got an equal 180. You guys know that from your last module. So that's how they represent angles. They're going to have a little arc in the dimension line itself. So as you go down below that example on page 121, you can see they're starting to use some different styles. So this is actually, they're going to use what they call like datum dimensioning. Now, datum dimensioning is a little bit different. Give you a couple different objects. A little rough shape there, but it is what it is. I'm not an artist, as you can tell. So what are they doing? They're using one reference point. So all these dimensions right here, let's say that's 2 inches. Let's say that's 6 inches. So they're using that one, this plane right here, to measure all those dimensions. And they're giving you every dimension. Same as here. They might use this right here as their datum. And they're measuring all these dimensions off of here. Same here. Measuring every little dimension off of there. As you can see, this gets very cluttered. That's what the example of 9.6a. You can see they're bringing that extension line out. Every dimension comes off of that datum reference line. Very cluttered. Very, very, very cluttered. It's probably, I've never seen it actually used in industry. Either have I used the zero plane dimensioning on the following page on 122. Zero to plane dimensioning gets a little goofy. I'm going to use the example on the lower right hand page of page 122. I'm going to try to draw this pretty close. Little angle up, straight. Something that looks like that. And there's a circle in here. Zero plane dimensioning is they pick an exact spot to be 0. And in this example, they use the center point. the center point to be 0. They got this 0, 2. They have this one 0, 1. So what does that mean? Anything measured off of here is going to be measured from that datum or that datum. So, let's say this dimension here, 1 inch. That is 1 inch from this reference to that reference. You can measure it in any direction. This is still 1 inch. See how that is falling in play. So, this, you don't actually, as you can see, they don't actually have the dimension lines in there. So this might be 1 inch. 1 inch. This could be 4 inches. So that 4 inches is from the center point of that circle up. No extension, no dimension lines. They just use extension lines. It gives you direct dimension. Same here. So they could have 1 inch here, 1 inch here. So these dimensions are coming off of this 0 plane. So this could be 3 inches. So they're coming out. It could be, so everything they're coming off of is at 0 plane. So this dimension is 3 inches over. So this might be 4 inches. So as you can see, everything is being measured off of what they call a 0 plane. 1 inch here, 3 inches here, 4 inches there, 1 inch. Same as here. 1 inch up, 1 inch down, 4 inches up. So that's how that is being used. This here is typically not used too much in industry. Actually, I've been in industry for a long time, 15, 17 years, and I've never seen a print like that. But we go through it just to show you examples of it. Typically, your prints are going to be kind of like you see on figure 911 on page 123. They're going to give you a few dimensions. You've got to calculate a few dimensions and things like that. So that example over there is a good example. We have two verticals coming off the plate. Extension line coming up. Extension line coming up. Let's say this plate is 6 inches. Okay, perfect. Extension line coming up. Might be 1 inch. What does that mean? So what's the distance between these two outer edges of these plates? We got to calculate it, right? We know these two dimensions. We know the overall dimension. 1 plus 1 gives me 2. 6 minus 2 gives me 4. So the dimension from here to there is 4 inches. That's how you're going to calculate that. Also in that little print, you see that word typical. So they have 0.25 TYP. What does that mean? That word typical means if you see that thing again, typically it's going to be the same size. So that tells me that applies to here. So this dimension here is 0.25. That's what that word typical. You can use it in weld joints too. So if we have 1/4 inch fillet weld here on side, 1/4 inch, might be typical. That means there's a 1/4 inch fillet weld here, 1/4 inch fillet weld here, and here. That's what that word typical means. Alright. Like I said, going through this stuff kind of quickly. If you are struggling, number one, you got to spend the time in there. Spend the time in the book. Read through it. Get an understanding of it. If you still have questions, come and talk to instructors. Next, we're going to go through tolerances. As you see figure 913, you see general tolerances listed there. This is the big one. You notice it says X, X, with the decimal point in front of it. That means any dimension on that print that has 2 decimal places is going to apply to that tolerance. I'm going to use 0.25. So if my dimension is 28.5, 50, I have 2 decimal places. That applies to that tolerance. So, a tolerance, because nothing is ever exact, it gives you a range which it can fall into. So our minimum would be 28.25. Our max would be 28.75. So that's the range that this dimension can fall within. It's plus or minus. Now, let's add a decimal place to here. That's 2 decimal places, as you can see. Follow that general tolerance. That applies to all dimensions on that print with 2 decimal places. Let's use the same example. 28.500. Now I have 3 decimal places. Now I have 3 x's there. Plus or minus 0.125, 1/8 inch. So now, since there's 3 decimal places here, that is applying to the general tolerances with 3 decimal places. What's my range? My min. 28.375, my max. So that is my range. Plus or minus. That's my tolerance. So that part can fall within there and still be acceptable. Now be careful, because sometimes they're not all plus and minuses. So let's say if we have 3 decimal places and only a plus 0.125. It only has a plus, not a minus. So what's my range? It has to be at least that big to that size. Or just vice versa. There's only a minus, so because you're only going one direction with that tolerance. Very important. This is always given to you in the title block, that general tolerances. Go in there. Look at the number of x's. That applies to that many decimal places on that print, or whatever dimension it may be. And as you go through there, it'll give you fractional, angular. So as you look, it says plus or minus 1/8 for fractional, angular plus or minus 2 degrees. Be sure you go through there and apply those. And be careful on test questions, because the question is going to give you what's my maximum dimension. So that means you add that tolerance to that dimension. So let's say if it was 3.5, and it's what's the max dimension that can be, and your tolerance is plus 0.25, so it'd be 3.75. So if they're asking you for a max or min, that means you apply those tolerances to that question. Now there's another type of tolerance that's explicit. That'll be given to you directly right on that print. So here's my dimension. Let's say it's 28.50, and it might say right above it, plus or minus 0.0625, 16. Now when you see that tolerance directly applies to only that dimension. You do not use the general tolerances anymore. It's called explicit tolerance. So that tolerance is directly used with that dimension and only that dimension. So that's the example that you see down here in figure 9.4. They're giving you the range that that piece can fall within. As you turn the page, you can see it. So you have 2.50 plus or minus 0.06. So that's giving you the exact tolerance. You do not use that tolerance, the general tolerances. You use the tolerance that is given directly to that dimension. And as you get to the right there's something they call a reference dimension. What is a reference dimension? They use the example 4.00. It's in parentheses. When you see that in parentheses, tolerances don't apply to that reference dimension. It's just a reference. A lot of engineers use that when they're calculating the amount of steel they're going to use. So tolerances do not apply to a reference dimension. It's given to you two different ways. In parentheses, or it might be 4.00, and it might say REF alongside it. Those are telling you that it is a reference dimension. So, tolerances don't apply to reference dimensions. Now, when you get into this chapter and you start struggling, what do? Contact us. One of the instructors will be here. We all have taught this blueprinting class. I think I've taught it for 8 years. Craig and John has also taught it for many, many years. So feel free to ask us any type of question, especially if you're struggling. Now, chapter 9 goes into what I call it GD&T, geometric dimensioning and tolerancing. What is that? The book shows you there's a T-joint. If you've been in the welding lab, you already know this. Now, if I tack this up and I make one weld on that side, you know that that part is going to pull over. You know that. You already know that. So, they use GD&T to help you reference that. There's a couple different ways. Here's kind of the old style. You'll see that in figure 921. So what are they doing? They're making this what they call a datum reference line. So, what does all this stuff mean? Well, this is my reference line now. This is my datum. This edge right here on this piece, on the vertical T-joint, it's going to be perpendicular 1/8 of an inch to datum A. So this piece right here has to be perpendicular to that datum within 1/8 of an inch. So as you weld that, it's going to tweak and bend a little bit and twist and all that good stuff. But when it's done welding, it's got to be perpendicular 1/8 of an inch to that datum. So all this is right here, this is referencing to that datum. So it's telling me that this vertical piece right here has to be perpendicular to this reference line. And as you go through the book, as you see page 125 on the right hand, there's a ton of symbols. We're not going to use all the symbols. Most of this stuff relates to a machinist. So as we start going through this, as you see page 126 and 127, you see figure 926 and 928. These are typically the symbols that we're going to be using. Go through there, they kind of explain themselves, like straightness, keeping it straight, flatness, usually perpendicularity, parallelism are going to be probably the primary two that you're going to be using. So as you look at parallelism, figure 927 on page 127, you can see they're using datum A. Maybe I should just draw it on the board. And they're referencing. So now we have two vertical pieces. Just like it shows you in the book there. They have a datum coming right off of here. Datum A. Right there. they're telling you that this right here, parallel within what, 0.0625 to the atom A. At 0.062, whatever it may be. So what are they telling you? This is being referenced to that. So this piece and this piece have to be parallel within a 1/16 of an inch. Parallel. That's what it's telling you. This is referencing to that datum. That's all it's telling you. Keep it simple. Very simple. Don't get confused. So this edge and that edge have to be parallel within a 1/16 of an inch. After weld. So they go through a couple other examples of like flatness, straightness, things like that. Go through it, read the chapter thoroughly, go through the review questions at the end. Keep in mind, we're here for you. I know we're starting to get very in depth into a lot of this stuff and more into the print reading. If you start getting lost, don't wait. Contact us as soon as you can. The sooner we get your problems issued, the sooner you can move forward and continue on. Now, I have many examples in the learning plan of some of these print reading activities. I have 3 file cabinets of just prints and examples of all this stuff. If you want more additional stuff to work on, which I would highly suggest, because print reading is a main thing as being a fabricator, being able to fabricate that part, tack it up, weld it within tolerances is very important. And especially in our industry up here in the Northwoods, everything is pretty much a custom fab shop. So print reading is huge. Make sure you utilize that print reading. Utilize your instructors as resources. The more time you put into it, the better you're going to perform on the shop floor. So make sure you utilize us the best you can. Utilize your time here at Nicolet, not only in the lab, but also on your online stuff. And like I said, we're going to set up times in this room here. This is room 103, where instructors are going to be here, and they're going to be doing lectures on print reading and weld symbols, probably 2 or 3 times a week. So make sure you utilize those times if you're getting confused. So thank you. That's it. Like I said, finish out chapter 9, read it thoroughly, and go from there.